Hello, welcome to a new short video tutorial on how to draw stuff with AutoCAD. Today's video tutorial is going to center around constructing a cross-sectional drawing or cross-sectional diagram for an earthworks activity. I'm going to insert a picture here of what the section is going to look like, and then we're going to go about constructing it using AutoCAD. Good, let's begin constructing the cross-section. What you notice from the drawing is that I have a trapezoidal excavation below ground level. And I'm going to start constructing by drawing in the base of the excavation. Now I know from the dimensions that the base is 5 meters wide. So I'm going to construct a line. Alright, let me choose a color here. I'm going to go with yellow because it's going to be a bit more visible. Draw a line. I'm going to draw a perpendicular line, and I'm just going to construct the line 5 meters long. There we go. There's my 5 meter line. Now what I'm going to do is construct a vertical line from the center of this horizontal line up, and I'm going to make it approximately, well, I'm going to make it exactly 2.7 meters long. No, I'm going to make it 4 meters long. There we go, 4 meters. Okay, now I know that the ground levels have been given in certain intervals moving away from the center line of the excavation. So I'm going to go ahead now and offset those lines using this center line as my reference. So I'm going to type in the offset command. The first distance is 3. So make this 3 meters away. I'm going to offset on the other side as well, since I am here. Now I need to move another 2 meters, so offset enter 2. And that one. And I'm going to offset again, offset enter 3 for the final one, as per our sketch. Clickety click. Good, so I have then the horizontal positions of the various survey points that I've received. So now I'm going to go and I'm going to construct a datum line for measuring purposes. A datum is a line from which I'm going to measure. I'm going to construct my datum line 1 meter below the base of the excavation. So offset enter 1 meter enter. There we go. And what I'm going to do at this point is I'm just going to extend it for the width of the section. So I'm going to use the fillet tool. I'm going to set the radius to 0. So I'm going to fillet this line and that one. Repeat fillet. This is now to start constructing my table at the base of the cross section. Good. Okay. So while I'm here, let me go and extend these lines. Extend these lines down. Here we go. So what I have here is the base of my excavation, and I have a datum line which is 1 meter below. Now, the survey information from my sketch tells me that the level of this point at the center line of at the bottom of the excavation is 95.9, which means that this datum must then be at 94.9. So I'm going to go ahead and put some text in. Put it in over here just to remind us what the number is. And we're going to put in text. I'm going to change the height here, I think, to 0.25, and we're going to type in the text of 94.9 meters. So I'm getting confused now. 94.9, and I want that text to be 0.25. Good. Right. 94.9, not 94.0. There we go. 0, 0. Good, so there I have some text. That's my datum, 94.9. Alright, now, okay, using the datum as a reference, I'm going to measure up from the datum in order to measure the ground levels at these various points. Okay, so the sketch told me that the ground level at the center line is 98.6. So that means that it is 2.7 meters above this the bottom of the excavation, because the bottom of the excavation was 95.9 and the ground is 98.6, and that's a change in height of 2.7 meters. Let me just confirm that quickly. 98 95.6, I'm sorry, I'm using my phone as a calculator, taking a bit longer, minus 95.9 equals 2.7. Okay, so if I draw a circle now from my datum, I know the circle has to be 3.7 meters in radius. And that gives me the position of the ground level above the center of my excavation, 98.6. Okay, so I'm going to just mark that quickly with a little circle, just because I'm here now. That didn't work very well. Let's do it again. Here we go. And delete this big one. Okay, delete that one. So let me do the one for the second point on the right, which is 99.1. So 99.1 minus the datum level, 94.9. And that is 4.2. So I'll go ahead and draw that circle in there, 4.2. Okay, so I can now copy the circle here, center, and paste it. Let's do away with that. Paste it at the center there. Right, so that's one way of positioning the ground levels. Another way I can go about doing it is by changing the color, maybe to magenta. And now what I'm going to do is using my lines. For the third point, I have to draw a line vertically up, which is 98.9 minus 94.9, which is 4 meters long. So I'm typing 4, and you see it draws a line 4 meters in length up to that point. For the final one, 99.6, 99.6 minus 94.9 gives me 4.7. So I'm going to draw a line again from this point up 4.7. You'll see that line goes to that point. Okay, let me quickly carry on with the rest of them. There we go. I've drawn in the rest of the ground level heights using lines measured up from my datum. I'm now going to go ahead and construct a polyline to draw in the ground level, and I'm going to make this line a different color. I'm going to make it color green. So here I'm going to join all the various lines, tops of the lines, to construct my natural ground level. There we go. Not so bad. I maybe want to change this line type to a different line type. Let's see if I've got any options. None at this stage. So let's go ahead quickly and change the line type, load a line type. I want to go with the dashed line type. It is over there. And that's the one I'm going to select. So this line I want to be dashed. There we go. Alright, so what I've essentially done is created the natural ground level above my excavation using the survey information from our sketch. Okay, so the next step in the drawing process is to construct the side slopes of my excavation, and I'm going to choose to use side slopes at a ratio of 1:1. So for every 1 meter horizontally, I move up 1 meter vertically, which is the standard slope. So I'm going to go ahead and draw a rectangle here, type in the command at 1,1, and you'll see that gives me a little square. I'm going to draw in the slope, and I'm going to mirror this particular object on the side, and now I have two slopes, and I'm going to copy them and paste them. Let me copy the other one. I'm going to paste that one over there. Good. Now I'm going to extend those to the ground line. And you'll see there they go. So that is the total excavation volume for this particular cross section. Let me go ahead and delete that. Alright, so what we need to do now is to actually construct our table with all the various bits of information in it. In order to do that, I need to work out how big the table needs to be. Now, I'm going to be drawing at a scale of 1:100. That's what I want in my viewport. So you need to do a quick bit of maths now. So remember, I'm drawing in meters. My viewport is in millimeters. And I want my text height to be 2.5 millimeters tall. That's why I selected a text height of 0.25. because if I say 2.5 millimeters times my scale, which is 100, gives me 250 millimeters. So if I'm drawing a scale of 1 in 100, if I want that object to come out in my viewport at a scale of, at a height of 2.5, then I need to draw it 250 millimeters long. But because I'm drawing in meters, I need to convert that back to meters. So 250 millimeters is 0.25 meters. So that's how I got the 0.25. Right, so now to create a table in which that text is going to fit. So I have some text already over here. Now what I'm going to do is I'm going to measure the length of that text so that I know how tall to make the rows in my table. So I'm going to measure now from this point to that point, and I get a line which is approximately 1.24. So I'm going to go with 1.25 meters. So I'm going to offset this datum line now. Offset, enter, 1.25. Oh, did I even do that correctly? Go for offset, 1.25. Okay, so now I'm going to offset this line down. I need another one over there. Let's go with that. Yes, that's fine for now. Enter. Okay, so in this table now, I'm going to put in the excavation levels in this row, and I'm going to put the ground levels in this row. So what I'm going to do is I'm going to extend my ground level lines down through the table now. Extend this point here, and I'm going to do all the purple ones. The purple ones. Good. We're getting there now. This one can go all the way through, and this one. We'll get there in the end, don't worry. Stay with me. I should just have deleted the others. Okay, so I'm actually going to delete these yellow ones because they're just causing me trouble. So that's what I have at the moment. Now what I need to do is I need to construct the lines from the excavation. So I'm going to do lines a different color just for the sake of clarity. I'm going to go with cyan, draw a line, make sure it's a perpendicular line, and I'm going to go from the point where this the intersection of the excavation and the ground line, and that's going to go down all the way because I need to enter both values in this table. Repeat. I'm going to do this one, and that just goes as far as that point. Again to there, and now this point over here. Down to there, and also continuing down to the bottom of the table. Good. So now I've constructed a very basic table with all these various lines in it. I'm now going to start populating the heights to put into this table. Okay, so let me begin. I'm going to copy this level of 94.9. I'm going to specify a base point over there, and I'm going to paste it over here. I'm going to rotate it. Rotate it 90 degrees. You'll see it looks like that. Now I'm going to move it, and I'll paste it over there. Okay, so 94.9 fits in nicely, except the level in this row is the level at the base of the excavation. So I need to edit this to say 95.900. Close text editor. 95.900. Now I can copy that, copy this text, paste it at the bottom, and now I'm going to put in the height at the center line above or on the ground level. So I'm going to change that, and that according to my sketch is 98.600 meters. Close text editor. Good, so let me now go ahead and put in the rest of the values as per our sketch. Okay, now that I've put in all the text, I need to still measure certain elements within the cross section. So what I don't have, or what I didn't have, is the height at the point where the cut embankment intersects the natural ground level. Now, how would I determine what that height is? This number these numbers I've put in here are just copies of other numbers. I still need to edit them now to put the right values in. Okay, so the datum here is 94.9, and the distance from the datum to the point where the slope intersects the natural ground is 3.4245 meters. So if I add 3.424 to 94.9, I get a level of 98.324. So I can go ahead and edit this text here to say 98.324 meters. And obviously at this point the ground level and the embankment level or the excavation level are the same. It's sort of the break point. So 98.324. Good. So that's populated. Let's do the same on this one. So 94.9 plus 4.152, and that, if I'm not mistaken, is 99.052. The level here, 99.052. So let me go and change this. 99.052. And it'll be the same here. 99.052. Good. Notice how I've kept all the text on the left-hand side of the vertical lines, except for this point here where the two vertical lines were too close together for me to put the text between them. So I moved the text to the right-hand side. That might also be a good idea for this text at the end of the table, just to make sure that everything fits actually inside the table. So I'm going to do that. I'm going to move it. This, and I'm going to use that as my base point. I'm just going to move it until it fits in. I think that's a good spot. Good. So that's my table. I'm just going to move my datum to inside the table. Okay, so there I have a basic table. Now what I want to do is neaten it up for the purposes of presentation. Okay, so I'm going to make my embankment or my cut. I'm going to make all the lines red so that they stand out with my plot style. That will make sure that they're all very visible, red. This ground line must be green, and I'm going to make all the other lines color 9. So select colors, color 9. There we go. So that's what it looks like at this stage. I'm going to make the table also color 9. So let's go and change that to color 9. And this little line here also needs to be color 9. No, wait, let's do match properties. Match properties. There we go. Great. So that's what I have at this stage. I am happy with the way it looks. Let me quickly just show you how to measure the cut volume of this particular excavation using the area tool. So measure area, all these vertices. We're going to get there. Be patient. Can be tricky. Okay, now I'm going to right click and say enter, and I get the area here in my display of 23.0418 square meters. So if you're doing a volume calculation, this is a very easy way to check areas. Good. Okay, so we're now ready to proceed to our setting up our page view to print out this particular cross section. I'm going to go to my layout, page setup manager. I'm going to do an A4 drawing. So remember to install the default plot style. Plot to PDF, ISO A4 layout 1:1 millimeters. Okay, close. So here is my viewport. We've dealt with viewports in other videos. I'm not going to do anything extreme here. I'm just going to show you how to set the scale. So if I double click on my viewport, the viewport is active. Notice how these lines appear differently. You'll see now that the dashed line is visible. I actually wanted this to be continuous, so let me just go ahead and change that line type to continuous. I'm just going to match the properties quickly here. See how I'm interacting with my model through paper space. Click that, and that must be solid lines. Alright, I want to set the scale on this. So you know from our discussions in class that if I now type in the scale Z, enter S, enter 1xp, that the drawing is now at 1 in 1,000, because it's 1,000 millimeters 1 meter unit in model space, and the units for paper is millimeters. So when I go 1xp, I have a scale of 1 in 1000. So I wanted a scale of 1 in 100. Now let's just do a quick check here. So if I type in, and remember 1 in 100 is a difference of 10, a factor of 10 between 1000 and 100. 100 times 10 is 1000. So let me just pretend that I didn't know the calculation, and I now wanted to zoom in or out by a scale factor of 10. So let's go Z, enter, S, enter, scale factor of 0.1 XP. And you'll see that the drawing gets even smaller. So clearly that's not the right direction. So let me type in Z, enter, S, enter, 1 XP, back to where we started, 1 in 1000. Now I'm going to put a scale factor in of 10 times bigger, so Z, enter, S, enter, 10 XP. And notice how I now have a drawing which appears to be reasonable for my page. I now want to check what the scale is. Did I do it correctly? So I'm going to switch off model and go into paper space. I'm going to quickly draw a line the length of the base of my excavation. That line, if I check it, is 50 millimeters long. Now I know that that line is supposed to represent 5 meters. 5 meters times 1000, to get it into millimeters, 5,000. 5,000 divided by 50 is going to give me 100. So I know then that the scale of this drawing is 1 in 100, which is what I set out to do. Good. Okay, so I've gone ahead and just made some small changes to the drawing just to make it more in line or in keeping with the way that we want our drawings presented. I'm just going to run you through some of the changes that I've made. I've changed all the text to style ISO CP. I've made these vertical lines in the lines of the tables continuous lines as opposed to dash lines. And I've put in a heading for the drawing, a title for the drawing, cross-section at stake value 100, and I've inserted the scale horizontal 1 in 100 and scale vertical 1 in 100, which is accurate for this drawing. So now let me go and check my plot that I'm going to make. So plot style loaded, drawing to PDF, ISO, etc, etc. Let me do a preview, and that then is what my final plot is going to look like. So thank you very much. I hope that you found the video useful. You must please practice and make sure that you can do these on your own. You can expect something like this as part of the evaluation for drawings 2, CDR2212. Thank you so much for your time.